Hear that? That's the sound of these drum brakes. I replaced the drum brakes, or the shoes rather, some time ago, and I used aftermarket parts. I've since made several attempts to try to keep those shoes quiet. I now am in possession of a brake lathe capable of machining drums. Therefore, I'm going to try one last thing, and that is to machine these drums and see if the noise goes away. A perfect opportunity to see how to machine drums. I've had these off several times, which makes them easy. Step one in the process is figuring out if there is enough material in the drum to machine away to begin with. We are fortunate enough in this case to where it tells us the max diameter is 255 millimeters. We will take our drum measuring gauge, zero it out, and look for, oh, yeah, it's on millimeters now. Look for, and you sort of 254.4, $255, we've got just a little bit. We don't have a whole lot here. We're only, well, about 0.7 millimeters away. So we'll have to be really careful when we machine these drums, at least on this side. My awesome lathe from Ranger. That being said, right now it is set up to machine discs or rotors. We need to switch it over. It's not that difficult to do. Remove this block, and we're going to install this guy. I like to start with a flat surface. So the mating surface here, I like to clean this with a Rolock disc. I do the same with the inside as well. And I'm leaving a little bit of dirt and debris here, but there's not a whole lot on the inside of this metal here for me to really be concerned about, if I'm honest. So I'm honestly going to leave that alone and just do this side and get it true. Before we get started, let's talk a little bit about the operation of the machine itself so you understand what it is I'm doing while I'm machining these drums. Now I've switched this over to drum machining mode, if you will, and this attachment comes out and it will machine the inside of the drum. The way this lathe works, it works on two axes, really. It works on this one and this one. What is this? X, and that's Y. So this controls the movement of this part of the machine in and out. There's a lock down here at the bottom that you can lock it into place. So you can run this down and it will make it so that this will no longer move. So you turn this and this will cause it to move in and out. When we're machining drums, we want this part to move in and out because this is going to remain stationary and the drum will be machined off of the stationary piece. In order to do that, we have this side over here. And once again, there's a lock in place up on top here. And if we run the machine in this way, out the other side, that also moves in and out. And as we use the machine, it will do this automatically. In fact, there's an electric motor in the back here that will cause this to move outward in this direction while this machines. This will remain stationary, but the drum will actually move away from our cutting head. When we're machining rotors, it's exactly the opposite. This part will move out, this part will remain stationary because we'll lock it down. So it's real important to understand how the machine works before we get started. Up here are the electronic controls of the machine. This turns the machine on and off. This controls the feed either for drums or for rotors. If it was drums, it causes it to move in and out this way. If it were rotors, it causes it to move on in and out this way. This is the speed control here. You can vary the speed of how fast this moves in or out, and that's important for the kind of cuts you're doing, whether you're doing fast cuts, slow cuts, things like that. Usually right about between 5 and 6 on this machine works. It just depends on what you're cutting. Cut too slow and sometimes it heats up and chatters. Cut too fast, same thing. So you've got to find sort of a little sweet spot. But if we turn it on, it causes the machine to start to spin. And if we want it to move in and out as if we're machining drums, push it like this. We can speed up the process here. There, you can probably really see it moving now. Now, if we were doing rotors, we would fit the feed down this way. I have to turn this knob out too. And this, as you can see, is moving outward. I'm going to start it out on 0 and get it ready to mount our drums onto the machine. This lathe is equipped with a quick change system that I've used to machine rotors in the past, and I've consulted with the manual, and it says that I can also do drums in a similar manner. So I'm going to try mounting it that way today. You out of the way. Looks straight and true. Now before we machine, one of the things we got to watch out for when machining things is noise and chatter. And this will help prevent that. So we'll wrap this around the outside of the drum. There we go. Now we need to position the head inside the drum here. But we just want to be sure that we can run all the way in to the base. If you can't, you got to get a little creative with how you position the head. Which, don't panic, it's not uncommon to have to do this. Now that I have the head mostly in position, and I'm sure that it's not going to encounter any obstructions when this moves in and out, I'm going to tighten it down. And I'm going to check its full run to make sure that it can do a full run, which it can. Now that I have the head correctly positioned, and I may not have mounted this how they want you to mount it, but I feel pretty good about it. I'm going to turn on the feed. And now we need to make it so that this just barely touches the inside of the drum. All right, that's the 0 position. What I can do now is bring this around. Oh. To 0 it up. Lock that down, and I'll know exactly how much I'll be taking off, which is important in this case. So I'm going to run it in with this handle all the way to the inside. I think that's a good position. You just need to get it past to where the shoes normally ride inside of there. I'm going to rotate this out. I needed to loosen this. Drum feed. Put it on about 4 or so. And let it do its magic. Now you notice you don't hear it chattering or singing. When they chatter and sing, it's not a good thing. And if it does, you might want to reposition this or cut a little less or change your speed. You don't want to take too much off. I have that little spot in there, that little teeny tiny spot. You can sort of see barely in this area. And that's with where we're at with this drum. You have to ask yourself, do you dare go more? And I only dare go like maybe 1 hash more is all I'm gonna do, just to try and rid myself of that. Looks like we did it. Now we just got to see if we measured it correctly. Pretty. Zero it up. Cannot be more than 255. Ha! Good. You want to sort of move this back and forth a little bit to find the true center. But I'm in spec. Barely in spec, but I'm in spec. Since we're addressing a noise, I'm going to go one extra step. I'm going to clean the dust out of inside here. There isn't a whole lot, if I'm honest. And I'm going to put a light sand on the outside of the friction material. Now, if this doesn't work, if I totally strike out here and it's still noisy, got to replace the friction material. There's just no way around it. You're so pretty, oh so pretty. Good question. Do I now need to readjust the brakes? Maybe a couple of clicks wouldn't be a bad thing. I'm thinking that's about right. That's good. Now that everything's set up on the lathe, it's a lot easier for the other side. It goes quick. Where are we at on this guy? About the same, 254. Yeah, real close. Real close. This is right on the ragged edge. I usually do that to help center it. I spin it on the cone. Just the habit that I got in. I'm used to doing it the old way. We have the new way now. I haven't found that it matters what way you mount this, in case you were wondering, just as long as you do mount it. And then it's secure, and on the outer edge. I wouldn't put it on this inner part, I'd put it on this outer part. It's kind of important to get the zero part set correctly. Fingers crossed. This one looks like it's a little bit more messed up than the other one. I didn't take this one as far because it's a lot closer to the edge. You can see we got a ways to go on this one. So we go. Still not done, there's still some left. See that shiny spot that comes around? We don't need to see that shiny spot. So close. We just got that little bit left. You can see right there. I have my doubts as to whether or not this one's actually going to survive. I'm going to go sand the shoes while that's doing its thing. That's kind of the nice thing about when you machine stuff is you can go off and do other things. Many times. Keep an ear open for that chatter I talked about. But I can go off and do other things while this is doing its thing. And that way you just keep your workflow going. Right there's what's left. And you know what? I'm gonna leave it. I don't think that's enough to affect anything, and when you're in this situation where you're right on the ragged edge, if not over the limit, you don't wanna go past it. So you don't wanna keep going and make it worse. I'm fine with leaving just that little bit. Now I'm gonna clean it out, remeasure it, and then we'll put it back on the van. So what are you thinking? Think I'm over? Think I'm way over? I could have went a little more. Barely a little more, but just a little more. I'm glad I stopped where I did. Yeah, 75 was about as far as I got. So we're still in spec. Barely, but still in spec. And that little bit right there, I don't think that's going to hurt anything. I'm going to use a torque stick when I install these. Whenever you're doing any machining like this or installing brakes, if you over tighten lug nuts, you can actually create a pulsation. Also, if after you're done doing this, you take it out for a test drive and you have a pulsation where you did not have a pulsation before, you didn't have it mounted in the lathe correctly, and you basically machined a pulsation into that item. It can and does happen. So that's why I do that spin. That's why I double check and make sure, try to make it straight. If it's not straight, you build in a pulsation. Let's see how good or bad we did. Well, kids, I suppose the lesson here is machining drums is fun, but make sure you figure out whether it's the front or back that's making the squeak noise before you get started on trying to fix something. Either way, you still figured out how to machine drums. I showed you my cool Ranger brake lathe. I'm going to put links in the description to that along with the drum measuring tool that I used in case you want to check those out. Other than that, I hope this information was helpful and useful to you should you need to machine drums. Machining drums and brakes or disc brakes has become something of a lost art. People are just replacing things straight out of the gate. But if you're short on cash, this might be the way to go. And you might check with, say, your local auto parts store or perhaps your local service facility. Check with them and see if they will machine the rotors or drum for you. You might just be able to take them off yourself, take them down to that facility, have them do the work for a small fee, and put them back on yourself, and away you go. You have options. Anyway, if you have automotive questions, I'd ask that you head over to EricTheCarGuy.com. Welcome video there to tell you about the stuff we have to help you. If you wish to connect with me socially, I can be found on Google+, Facebook, Twitter, Instagram, links down below. I post repair videos on Friday, so stop back and see me then. And I close each of my videos with be safe, have fun, stay dirty. I'll see you next time.